Good evening. Myself Chaitanya. I am going to teach you geotechnical engineering, and my topic today was compaction of soils. And let me give you the idea what weightage geotechnical engineering carries in GATE. Okay. In GATE, geotechnical engineering carries 10 to 12 marks. 10 to 12 marks for a single subject. It is very huge. So you can say that if you are good at geotechnical engineering, you have pretty good chances to clear GATE with good score. Okay. And let me come to my topic today: compaction of soils. My topic today: compaction of soils. What is compaction? Reduction of volume of the soil by expelling out the air present in the soil is called compaction. Everyone know that soil will be represented in a three-phase system. This is air, this is water, and this is soil solids. So, what is compaction? If we expel out this air totally, 100% compacted soil. If we are going to expel out this water, it is called consolidation. And consolidation. Here, we are going to reduce the volume of soil by expulsion of pore water. This is how we are going to reduce the volume of soil in consolidation. Okay, and this is the basic difference between consolidation and compaction. This is pore water expulsion, this is air expulsion. And there is one more difference. This is an instantaneous process. And this is a long-term process. Means if there is soil and if you are going to drop a huge weight on this soil, automatically some air will get expelled out instantaneously, then and there. So it is called compaction. That is why it is called instantaneous process. But coming to consolidation, this is soil on which you are going to make a structure, a house or a chimney or whatever. On this structure will impart stresses on this soil, and due to which excess pore water pressure will get dissipated, and after a long time all the excess pore water will get dissipated and the soil reaches 100% saturated state. That is called consolidation. Then we can say consolidation is complete. And now there is one more thing called plastic rearrangement of solids. Plastic rearrangement of solids. This happens in plastic clays. This happens in plastic clays, but it is not considerable in sands, dry sands, may not be in silts also. Very small amount of plastic rearrangement happens in silts. And now we are going to what is by compaction of soil. What happens to a soil? What happens to a soil? One, void ratio will get decreases due to compaction. 2, degree of packing increases. 3, dry density increases. 4, main point, shear strength of soil will get increased due to compaction. These are the effects. And now we are going to the how would we be able to know how much maximum density the soil is able to attain? At what water content it will attain maximum density, maximum dry density mainly. How you are able to know? How you are going to know that? For this, there are two tests which are conducted in laboratory. One, standard Proctor test, and two, modified standard Proctor test. And Indian Standard Code adopted these two with slight modifications and then called them as Indian Standard Light Compaction Test, Indian Standard Heavy Compaction Test. It's like both are same, but there are slight modifications in specifications of test doing process. So I am going to say the specifications of this. How we are going to conduct this? One, how we are going to conduct Proctor test. First of all, we are going to take a mold which is of 1000 cc volume, and in that we are going to fill up the soil in 3 layers. After filling the soil for 3 layers, we will drop the hammer with a free fall of 30 centimeters for light compaction, 45 centimeters for heavy compaction. Like that, we are going to drop for 25 times for each layer. And the weight of the hammer, what is the weight of hammer here and what is the weight of hammer here, we are going to discuss now. And we will assume some water content, maybe 16%, 14%, 18%, and we will start from there, and we will be increasing the water content and repeating our trials. And we are going to make a graph out of that. Increasing the water content and finding out the dry density, and we are going to make a graph out of that. Now, in Indian Standard Light Compaction and Indian Standard Heavy Compaction, what is the weight of hammer here? 2.6 kg. What is the weight of hammer here? 4.9 kg. What is the free fall here? 31 centimeters. 31. Here 45 centimeters. 3 layers. 25 blows. 5 layers. 25 blows each. Mold volume is same, 1000 cc. 1000 cc. This is the specifications of this light compaction and heavy compaction. And here there is a small bit which can be asked. Suppose they will ask like this: ratio of compaction effort or ratio of compaction effort to ISLC to ISHC, light compaction to heavy compaction. So we are now going to calculate the energy we have put in compacting the soil in the mold, in light compaction and heavy compaction. How to calculate the energy spent? Multiply these things. 2.6 kg into 0.31 meters. I am giving it in meters, free fall. Into 25 blows into 3 layers into G, gravity, 9.81. This is the energy spent, total energy spent here. I think you can make it out. Kg, meter per second square. You can make it out by through units. And for this heavy compaction, same thing. 4.9 into 0.45 into 5 into 25 into 9.81. You will get, this is standard value, you will get 4.56, approximately 4.56. If you can remember this value, better. Then, if not, then also better, you can calculate easily. Now, now I said something about compaction curves. So after doing the tests for different water contents, maybe for 14, 16, 18%, for 20%, 22%, for different water contents, we will calculate dry densities for every water content and we will make a graph out of it. That is called compaction curve. I will draw a sample graph. How it look like? It will look like this. Here, water content in percentage. Here, dry density. It will look like this sample graph. This is called maximum dry density. This is the optimum moisture content. Optimum moisture content means the moisture content at which maximum dry density occurs is called optimum moisture content. This is the sample curve. And now, question here is, do this curve remain same for every type of soil, clay, silt, sand, etc.? Do this curve remain same for whatever the compactive efforts we are putting? Remain same for light compaction, remain same for high compaction? Do they remain same? Now answer to this is no, they will not remain same. But the shape of the curve will remain same. How it is going to change? I am explaining now. Let us suppose first we are going to draw the curve for light compaction. Let us suppose the graph is this. This is the OMC. And now if we do the test for the same soil, but with the same samples, the same water contents, but the graph will change like this. For heavy compaction, it will change like this. This will be the maximum dry density. Here, this will be the maximum dry density. OMC will get shifted. So what you observe here? If we are increasing the compactive effort, the curve will get shifted to left. Or optimum moisture content will decrease. Maximum dry density will increase. This is the effect of compactive effort on compaction curves. And one more thing. If we change the type of soil, now we are going to change the type of soil. This is the curve for clay. Let us assume this is the curve for clay. And now, if you are doing the same test with same water contents in silt, curve will get shifted like this. Silt. Same test, the same water contents we are going to do for sand now. Then the curve will get shifted like this. For gravel, furthermore left. Ultimately, what I am trying to say here is, if the grain size of the soil increases, the curve will get shifted to the left. You can see this in the descending order: gravel, sand, silt, clay. Grain size is in the descending order. If the grain size increases, curve will shift left, and the dry density will get increased, maximum dry density and the optimum moisture content will get decreased. This is the thing. And furthermore, if we are seeing this gradation, like this is clay, but highly compressible clay, CH. I think you are well aware of the symbols. If now we are going to CI, intermediately compressible clay, it will go like this. Now, low compressible clay, it will go like this. So what we are trying to observe here is, if the plasticity get reduced, then again the curve will shift left. The same thing in silt also. Now, for sand, there is a concept called bulking of sand. So let me explain what is this bulking of sand. Bulking of sand is, if you are adding some water to the dry sand, 4 to 6% of water content to the dry sand, what will happen? The water will get absorbed to the surface of the soil. Sand is solid. It will get absorbed, ADSORBed. This will be the soil structure. And after the water get absorbed to the surface, apparent cohesion, this will gain apparent cohesion and will now come into a honeycomb, a comb-like structure like this. Like this. It will gain a comb-like structure, honeycomb-like structure. So volume of soil, volume of sand increases. In 4 to 6% water content, volume of soil increases due to the apparent cohesion gained. This is called bulking of sand. So at 4 to 6 watt, so if we are going to see the same compaction curve for sand, it will look like this. So, as a civil engineer, it is not advisable to buy sand at 4 to 6% water content, because when you are loading it in the truck, you can see volume, you can see high volume, but in reality that was not high volume. It just increased due to the combing. So it is not advisable to buy it. This will be the compaction curve in case of sand. And now, there is one more concept called relative compaction. This is a parameter actually, relative compaction. What is relative compaction? This parameter is used to find out how much we are able to make the soil, how much we are able to get the dry density in the field. Like if you say the formula of this, gamma d field by gamma d max. For the equations we have, we can find the gamma d max. Obviously, we will know the water content, what is the water content, what is the specific gravity. With this, we can find the gamma d max. This one formula, we can find the gamma d max. Theoretically we can find it. But on the field, we will not be able to achieve the same dry density which we are going to get theoretically. So this is the ratio which shows how much we are able to achieve in the field. This is the ratio of the relative compaction. If the relative compaction value goes to be 80%, 90% like this, 90% in the sense means we are able to achieve 90% of the maximum dry density in the field. This is the meaning of this 90% relative compaction. And factors affecting compaction. What are the factors which will affect the compaction? First factor, compactive effort, which we discussed now. The compactive effort increases, the compaction curves will shift left, OMC will decrease, dry density will increase. This is what we discussed already. Second, type of sand, type of soil, we discussed it. Water content, the plasticity. These are the factors which will affect the compaction. And now, so how this compaction affects the engineering properties of the soil? Due to this compaction, how the engineering properties of soil changes? One, structure. So I will make a tabular form so that it will be clear, concept will be clear. I will make a tabular form here. First one, structure. What is this? This is dry side of optimum, dry of OMC. This is wet of OMC. Means this is the curve. This is called dry of OMC. This is called wet of OMC. Wet side, dry side. Okay. And how the structure will get affected? Only the clay, mainly the clay structure will get affected by this compaction. But for sands, etc., we are not able to bother. We are not going to bother. Only the clay and the particles which are less than clay will get affected. Here, the structure is flocculent here. On the wet side of OMC, it will go to dispersed. Second, permeability. Permeability. If you increase the water content, permeability decreases, obviously. So, but if we compare these two, permeability is more in this side than this. Here the permeability will be minimum at OMC. Number 3, swelling. Swelling will be more dry of OMC, less at wet of OMC. And 4, shrinkage. Shrinkage is less here, high here. These are the effects on engineering properties of the soil due to compaction. There is some more compressibility. Compressibility, which is less here and which is high here. And there is one more concept here. If we are using high compaction, high compactive efforts, the soil structure will be broken down and here the compressibility will be more. If we are using high compactive efforts, soil structure will get broken down and the compressibility will gain weight. Next, these are the factors affecting engineering properties of the soil due to compaction. Now, if we go for and one more thing, let me make it clear. For sand, we can achieve 100% saturation or zero air voids. For clay and silt, we will never be able to achieve 100% saturation or zero air voids because as soon as we lift the hammer out, some air will get into the pores of this clay or silt. So we will be dry density, maximum dry density in clay can be achieved at 85 to 95% saturation for clay or silt and silt. For sand, at 100% saturation, you will be able to achieve maximum dry density in sand. And by this, I think I can end this compaction. There are some more topics here in compaction, like what are the type of rollers used, where rollers are used, where vibrators are used, where rammers are used, where pneumatic rollers are used, shift foot rollers are used, how they are, in what way they are effective, for what type of soil they are used. These things we can discuss afterwards. By this, I am completing this compaction and thank you. Hope you understood.